So briefly reviewing what we have to do. So this is the step equivalent static method. Clause 7.6 will give you the steps that are required to find out the um, this thing. Okay. So how we have to do? What we have to do first is we need to calculate the design base year. So design base year ആണ് നമ്മൾ ആദ്യം കണ്ടുപിടിക്കേണ്ടത്. Once we compute the design base year, it has to be distributed to the various floors. Okay. So ഇതാണ് സെക്കൻഡ് സ്റ്റെപ്പ്. ഈ രണ്ട് സ്റ്റെപ്പാണ് പരീക്ഷയ്ക്ക് നിങ്ങൾ ചെയ്യേണ്ടത്. Okay. Now this method is applicable only for regular buildings with a height less than 15 meter in seismic zone 2. So that is the validity of this procedure. Okay, this is applicable only for seismic zone 2 with എന്താണ് പറയുന്നത് with height less than 15 meter. However, if it is in other zones, okay, if it is in other zones, still we have to do this analysis also. Okay, because whatever value we are getting from this will be the minimum design value. For example, there are in other cases what we have to do is if this criteria is not satisfied, for that building we also have to do response spectrum analysis. Okay, if this criteria is satisfied, this criteria mostly satisfied in which cases up to let us say 4-story or 5-story. In zone 2 only this will be valid. മനസ്സിലാവുന്നുണ്ടോ? Up to 15 meter എന്ന് പറയുമ്പോഴത്തേക്കും up to 4-story or 5-story in seismic zone 2. In such cases only this will be valid. In all other cases we will also have to do എന്താണ് dynamic analysis or response spectrum analysis. However, even if we are doing response spectrum analysis, we also have to do this method also. Reason is whatever we are getting from this method will be the minimum that we have to use. For example, sometimes when we do response spectrum analysis, we will be getting, let us say, some 900 kilonewton as the base shear. Okay. However, response spectrum gave us 1000. Okay. In such cases, we should be taking this 1000, that is the value given by this linear static method. Okay, because this should act as the minimum value. I hope what I am telling is clear to you. So step number 1 is this VB is equal to AH into W. This is step number 1. And how AH has to be calculated, I will tell you briefly. AH comprises of, the formula for AH is AH is equal to Z divided by 2 into I divided by R multiplied by SA divided by G. This is the formula for AH. Okay. This is the formula for AH. Now here Z is known as the zone factor. As you are aware that the entire country is divided into different zones, and based on each zone, the intensity of the earthquake that can occur there is quantified in the form of zone factors, and Z represents the zone factor. So if I want to check the zone factor, all I have to do is simply go to the annex. So if you go to the annex, here the zone factor is given in annex E. For example, we are talking about Jammu and Kashmir. So look for Jammu and Kashmir here. So you can see Jammu and Kashmir means Srinagar. It is given in zone 3, zone 5. Okay, can you see here? Srinagar. Zone 5, it is 0.36. Okay, so in that way you can get the seismic zone value of all the important cities in India. If the place is not available here, you can directly read from the seismic zonation map by locating it on the zonation map. But mostly for the question that you are getting in examination, they will be towns that are available here. You can take it from here. Okay, I hope this is clear to you. So that is the term Z. Now next term is I. Now I means importance factor. I means importance factor and R means response reduction factor. Now let us see where to get I and R. So response reduction factor is given here. In table 9 you have response reduction factor. So various types of buildings are given. We only require to know these two, that is special moment resisting frame as well as ordinary moment resisting frame. Okay, so ordinary moment resisting frame it is 3 and special moment resisting frame response reduction factor is 5. So these two are typically required for in our case. Then next is importance factor. So importance factor you can get from table 8. So if we look into table 8, so table 8 if you are looking, what it is telling, there are 3 different categories given. First one is normal building, second one is an intermediate category is given, and third one is all other buildings. So in our question nothing is mentioned, so we will take it as a normal building. Okay, we will take it as a normal building. This is intermediate category 2, so there the value is 1.2, and if it is critical or lifeline structures, okay, if it is a critical or lifeline structure as mentioned here, then you have to go for 1.5. Okay, so in this case we will be taking 1 because nothing else is mentioned regarding the structure. Okay, here you can see yeah, however, despite in spite of the values that are given here, if you want to ensure that your structure is having more safety, you can choose a higher value. Okay, but these are the minimum criterion that should be satisfied according to the code. Now next term is SA divided by G. What is this SA by G? So SA by G is basically this. This is the design response spectra and this is the SA by G. So what we have to do is, first thing we have to calculate is the time period of the structure. And once we calculate the time period, then we need to know what is the soil type. So SA by G is given for 3 different soil types. Okay, so rock or hard soil, then medium or another name is stiff soil, medium or stiff soil, and then soft soil. So depending on the soil type, we have to choose the corresponding graph, and depending on the time period that we are having, we go to the graph and get the corresponding value of SA by G. Okay, and another important thing we have to understand is two different, this is known as the design response spectra. Okay, design acceleration response spectra. Okay, two different are, and also this is for 5% damping. Okay, two different design response spectra is given in the code. One thing regarding design response spectra is it is an acceleration response spectra. Another thing is two different response spectra is given in the code. One is for static method and another one is to be used for response spectrum method. And instead of doing the graph, an easy way to find this out is provided as, this is given as a formula here. Okay, so you only have to make use of this formula to find the values. I hope you are clear. Okay, so in this way you can find out the various values. Okay, so then another important thing is from where to get the, which time period formula we have to use.
സാറേ വിശാലിനെ അഡ്മിറ്റ് ചെയ്യും, മെസ്സേജ് അയച്ചായിരുന്നു കയറാൻ പറ്റുന്നില്ലെന്ന് പറഞ്ഞിട്ട്.
So if you go to the code, different time period formulas are given. Okay, so for bare frame without masonry infill, then these formula have to be used. For bare frame without infill, these formula have to be used. Okay, different class of building. Then other cases, so many cases are given, and there is something known as other buildings. So other buildings means when we have a building with infill, in that case we have to make use of this formula, that is other building. Okay, and in both the cases this should be taken as the minimum. In all the cases this has to be taken as the minimum value. Okay, I hope the idea is clear. Whatever is given by this first formula, this should be taken as the minimum, this should be taken as the critical value. That is, if this value is more, then you have to take this, and however this should also be checked. Okay, now let us see how to do the problem. So we will try to solve this problem. So this is what we are having. So one more formula for time period was there, that is 0.075 into h raised to 0.75. Okay, so 0.075 into h raised to 0.75. This is another formula. അപ്പം ഇവിടെ നമ്മൾ നോക്കേണ്ടത് ഫണ്ടമെന്റൽ ടൈം പീരിയഡിന്റെ ഫോർമുല എന്ന് പറയുന്നത്, ബിക്കോസ് ദർ ഈസ് മേസൺറി ഇൻഫിൽ, വി ആർ യൂസിങ് ദിസ് ഫോർമുല. ഓക്കെ, so we need to find it out along the short direction. So let us find it out along the short direction. So along the short direction, let us put it as ts. We will get the value as 0.09. H means the total height of the building, that it can be found out as 13.5. You simply add this, you will get h value, that is in meter. So 13.5 divided by square root of d. D is the dimension in the direction you are considering. Okay, so plan dimension in the direction we are considering is 15, that is shorter direction. So you'll put 15 here. You will get the value of, and then this. How much is the value? Okay, so this value you can get it as 0.314 second. So this value is coming as 0.314 second. This is the value you are getting. Now along the longer direction, if you look the longer direction, you will get it as 0.09 multiplied by 13.5 divided by square root of 20. 20 is the longer plan dimension. So here if you solve it, you will get it as 0.272. Okay, this value is coming as 0.272 second. Also, if we are trying to use the bare frame formula, that is without any reinforcement, so there what we will be using is, we will be using 0.075 into h raised to 0.75. Okay, so this if we do, we will get the value as okay, we will get the value as, I think, 0.352 second. Now what we have to do is, this is the basic different time period values. Now we need to go to the code. So when we go to the code, what we can see is, where is the code? So here if you go to the code, you can see that where is it? Okay, so what was the soil type? എന്തായിരുന്നു soil type? Soft soil. So we will look here. So soft soil, if the time period is between 0 and 0.67, If the time period is between 0 and 0.67, then you have to take the value of SA by G as 2.5. Okay, so in this case, all the value of SA by G is coming in this region, so 2.5. Okay, so you will take it as 2.5. So when you are having different time period values, sometimes you may get different, one may fall here, another may fall here. What you have to do is take the largest SA by G value for all the time period. Okay, of all the time period, whichever you are getting as the largest SA by G value, take that SA by G value. Is that clear? Clear or no?
Yes.
So here we will be using the SA by G value, that is 2.5 in both the directions for soft soil. Okay, so these are the different values. Zone factor, everything is given here. Now we have to calculate the base shear. So base shear is VB is equal to alpha H. Alpha H is nothing but എവിടെയാണ് Okay, alpha H is nothing but Z by 2. Z is 0.36 divided by 2 into I by R. I is importance factor. Importance factor we took it as 1. Then R, it is and then special moment resting frame. So it is 5 multiplied by SA by G. SA by G is 2.5. Okay, so this is alpha H multiplied by W. W is a seismic weight. You simply add all the weight, you will get the seismic weight. So that is 25250. Okay, if you simplify it, you will get the base shear value as you will get the base shear value as എത്രയാ വരുന്നേ? You will get it as 2272.5. Okay, you will get the value as 2272.5 kilonewton. What that means is, ഇതാണ് നമ്മുടെ building. The shear that is going to act at the base, that is the base shear. This value is this value, 2272.5 kilonewton. Okay, now what we have to do is, this base shear we need to distribute as to each of the different floors. ഓരോ ഫ്ലോറിലേക്കും നമുക്ക് ആക്ട് ചെയ്യുന്ന ലോഡായിട്ട് ഇതിന് എന്ത് ചെയ്യണം, ഡിസ്ട്രിബ്യൂട്ട് ചെയ്യണം. കാര്യം നമ്മൾ പഠിച്ചെങ്ങനെ, ബിൽഡിംഗ് ഉണ്ടെങ്കിൽ മാസ് ഈസ് ലംപ്ഡ് അറ്റ് ഈച്ച് ഫ്ലോർ ആൻഡ് അറ്റ് ഈച്ച് ഫ്ലോർ വാട്ട് വിൽ ഹാപ്പൻ, എർത്ത് ലോഡ് ഗെറ്റ് ഇൻഡ്യൂസ്ഡ്. ആ കോൺസെപ്റ്റ് ആണ് ഇവിടെ യൂസ് ചെയ്യുന്നത്. ഓരോ ഫ്ലോറിലും ഡെവലപ്പ് ചെയ്യുന്ന ഫോഴ്സ് നമുക്ക് കണ്ടെത്തണം. ദാറ്റ് ഈസ് ബൈ ഡിസ്ട്രിബ്യൂട്ടിംഗ് ദിസ് to the upper stories. Okay, and what is the formula using which we are going to distribute? We are going to distribute in such a way that Fi is equal to ഒരു ഫോർമുല ഉണ്ടായിരുന്നല്ലോ, it is given in the code. Okay, in accordance with this formula we have to distribute, that is Wi Hi square divided by sigma Wi Hi square into Vb. Okay, so this is the formula that we have to adopt, that is force at each level is equal to Wi Hi square divided by sigma Wi Hi. എങ്ങനെയായിരുന്നു? Okay, multiplied by VB. This is the, so here what we have to understand is the HI for each floor. I represent the floor level. HI for each floor is nothing but the height up to that floor. So for example, H1 will be nothing but whatever is the height of the first floor. H2 will be nothing but the height from the bottom to the first floor. H3 will be height from bottom to the top. Similarly H4. So easier to solve this in a tabular form. Okay, so we can make use of a tabular form like this. So these are the different seismic weight values. After we know, we write the first one is 3.75 from the ground to the first floor, then from the ground to the second floor, then from the ground to the third floor, and from the ground to the top floor. Then simply WHI square, you can get the value here. Okay, so once you have WHI square, I think you can calculate and find sigma WHI square here. So that can be found out here. So once you have sigma WHI square, then this value will be nothing but whatever is given in this column divided by this sum into, so for example, if I put this as X and this as Y, then it is nothing but X divided by Y into VB. For each row, you simply have to do that, then you will be getting these values. These values. Is that clear? How you are getting FI? FI കിട്ടുന്നത് മനസ്സിലായോ? Clear ആണോ? Please tell me if it is clear.
Yes, sir.
Okay. Now after getting that, you also have to calculate one more. So once you do that, what you are going to get is this. You will be getting something like this. So you are going to get a value here like this. This will be F1, this will be F2, this will be F3, and this will be F4. Now we also require the story shear. Story shear means the shear that is acting at each story level. Okay, so for example, if I am taking this particular story level, the only shear that is going to act is F4. Okay, whereas if I am taking the next story level, if I am taking this story level, the shear that is going to act will be F3 plus F4. Whatever load that is above it is going to act as the story shear in that particular story. So it is going to be F3 plus F4. If I am coming here, it will be F2 plus F3 plus F4. And if I am coming here, it is going to be F1 plus F2 plus F3 plus F4, which is going to be nothing but the base shear itself. Okay, so that is what I have done here. So 1017.97, that is the story shear here. Okay, in the next one I have added that too, so this we will be getting. In the next one, you will be adding all the story shear till here, and you will be writing here. In this one, the entire thing will be written here and written here. Okay, so we have to represent that in a diagram like this. So basically this value is the F1 value, this value is your F2 value, this is your F3 value, and this is your other value. And how you are representing it, you will join them by straight lines. Okay, and what is the shape of this? This looks like an inverted triangle. So this is the load distribution in IS 1893, inverted triangular distribution. Okay, it looks mostly like an inverted triangle. Now story shear distribution, this value is given as wrong. This value is, I think this is 1017.97, this value. Okay, I think it is almost correctly given also. So, and the next value that we will be having is this value, that is 1737.6. Here 2165.97, and here 2272 0.5. So this is the value. Now here what you have to understand is this we are assuming that they are linearly distributed. So we are drawing these kind of lines. However, with regard to story shear, for a particular story, from here till here, the entire story will be having the same constant shear force. That is why we are using this kind of a representation. Instead of joining them by straight lines, the story shear remains constant in any particular story. That is why we are following this kind of a pattern. Okay, I hope this is clear to you. Is it clear? So for the exam, basically all that you require is you need to draw these two diagrams. ഈ രണ്ട് diagram വരച്ചു കഴിയുമ്പോഴത്തേക്കും this will be a 10 mark or a 15 mark question. Okay, so I will give you a problem where you have to do from scratch. That is, you will be given the plan. You will be given the plan details will be given to you, column dimension, elevation, everything will be given to you. Then what you have to do is you first have to do the dead load calculation. Dead load will be nothing but the self weight, plus if there is any superimposed dead load, that also. Okay, and you have to lump them at each floor also. So for example, if you are having the first story, the total weight of the first story will be slab weight plus half of the column weight on the top and bottom. Okay, so above it, half the column weight will come on this floor. Similarly, below it, half the column weight will come on this floor. So in that way you have to calculate. Plus live load has to be taken. Now live load, when you take, you don't have to take the entire live load. What the code says is, when you are considering live load, if it is up to and including 3 kilonewton per meter square, you only have to take 25% of the live load. And if it is above 3, then you have to take 50% of the live load. Okay, so this is the percentage of imposed load that should be used, or live load that should be used in the load calculation. Okay, I hope it is clear to you. And one more thing is also there regarding load calculation: full dead load plus appropriate amount of imposed load. Okay, so this is the appropriate amount of imposed load. So it is given here how to calculate the seismic weight. I hope it is clear to you. Is it clear or no? Is it clear? എന്തെങ്കിലും സംശയമുണ്ടോ ഈ പറഞ്ഞതിനകത്ത്? എന്തെങ്കിലും സംശയമുണ്ടോ? Any doubt in what we talked about? Anything?
സാർ ഒരു 5% ഡാമ്പിംഗ് പറഞ്ഞിരുന്നില്ലേ?
അതെ,
അത്
നമ്മൾ അസ്യൂം ചെയ്യുന്നത് building is having only 5% damping. നമ്മൾ സ്റ്റാൻഡേർഡ് previously code allowed to consider higher amounts of damping also, but the current version of code is saying that as a standard you take 5% of damping, irrespective of the material type or irrespective of the facilities in the building for damping, you take it as 5% damping.
Okay.
Is it clear?
Yes, yes.
Okay, അപ്പോൾ ഇതാണ് നമ്മളുടെ എന്തുമായി ബന്ധപ്പെട്ടിട്ടുള്ളത്. This is the problem that is available for you in the examination also. Okay, എക്സാമിന് ഇപ്പോൾ ഈ ഒരൊറ്റ പ്രോബ്ലം മാത്രമേ ഉള്ളൂ. ഇനി ഒരു പ്രോബ്ലം ഉള്ളത് മോഡ്യൂൾ 2-ലാണ്. Okay, very simple problem. Anybody can do very easily. Okay, so one assignment problem also I will be giving regarding this, so you can practice that also. Okay, now the next topic that we have is, I think, in addition to this, there is something known as displacement and drift requirements that are provided in the code. Okay, and there is also something known as torsion. Okay, so ഈ ഡിസ്പ്ലേസ്മെന്റ് ആൻഡ് ഡ്രിഫ്റ്റ് റിക്വയർമെന്റ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ കോഡിനകത്ത് ഇവിടെ കൊടുത്തിട്ടുണ്ട്. കണ്ട് ഡീഫർമേഷൻ എന്ന് കൊടുത്തേക്കുന്നുണ്ടോ? 7.11 7.11 കണ്ടോ? ആ കൊടുത്തിരിക്കുന്നത് ആണ് ഡിസ്പ്ലേസ്മെന്റ് ആൻഡ് ആ കൊടുത്തിരിക്കുന്നതും ഈ 7.11 ഈ അവസാനം വരെ കൊടുത്തിരിക്കുന്നത് മാത്രമാണ് ഡിസ്പ്ലേസ്മെന്റ് ആൻഡ് ഡ്രിഫ്റ്റ് റിക്വയർമെന്റ്സ് എന്ന് പറയുന്നത്. ഓക്കെ, സോ ബേസിക്കലി ഫസ്റ്റ് വൺ ഈസ് സ്റ്റോറി ഡ്രിഫ്റ്റ് ലിമിറ്റേഷൻ. ഓക്കെ, സ്റ്റോറി ഡ്രിഫ്റ്റ് ലിമിറ്റേഷൻ എന്ന് പറഞ്ഞാൽ എന്താണ് ഈ സ്റ്റോറി ഡ്രിഫ്റ്റ്? സ്റ്റോറി ഡ്രിഫ്റ്റ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഇപ്പോ ഇതാണല്ലോ നമ്മളെ ബിൽഡിങ്. ഇത് ഡീഫോം ചെയ്യുമ്പോഴത്തേക്ക് എന്താ സംഭവിക്കുന്നത്? ഇതൊരു സൈഡിലേക്ക് ഇങ്ങനെ ചരിയും അല്ലേ? സ്റ്റോറി ഡ്രിഫ്റ്റ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ബേസിക്കലി ഇറ്റ് ഈസ് ദിസ് തിങ്, ദ ടോപ്പ് സ്റ്റോറി മൈനസ് ബോട്ടം സ്റ്റോറി. ഓക്കെ, ഈ രണ്ട് ഡിസ്പ്ലേസ്മെന്റിന്റെ ഡിഫറൻസ് ആണ് എന്ത്? ഇറ്റ് ഈസ് ദ story drift. Okay, the displacement difference between these two will be the story drift. That is basically, if it is vertical, if you consider the bottom of the story as the base, the top will be displacing like this. Okay, so whatever has happened here will be the story displacement. And how do you calculate the story displacement? Displacement of the top minus displacement of the bottom. Okay, here you will notice that it is given as some decimal. That means what they are doing is they are dividing the story drift by the story height also. Whatever is the story height, you divide this value by the story height value. Okay, then it should not be exceeding this value. അതാണ് story drift എന്ന് പറയുന്നത്. Okay, so other things you can simply reproduce it or simply read from it and you can understand on your own. Another important thing is with regard to spacing between the buildings. Okay, if two buildings are close to each other, what will happen? What will happen if two buildings are close to each other?
വൈബ്രേറ്റ് ചെയ്യുന്ന കൂട്ടിയിടിക്കും.
കൂട്ടിയിടിക്കും. അതിനെയാണ് പറയുന്നത് പൗണ്ടിങ്. That is known as pounding. Pounding means two buildings hitting each other and causing damage to each other. So to avoid pounding, there has to be a minimum separation between the buildings. Okay, and how to calculate that minimum separation is given by this formula. And what these things are, you can simply read and understand. Okay, so that is regarding displacement and drift requirements. Then another concept I want you to understand is regarding torsion. Okay, so for example, this is the plan of a building. What do you notice? Albert, what do you notice? Do you notice anything? Misbah, do you notice anything? Hello.
Yes, sir.
Do you notice anything?
A plan drawn.
Beyond that, what is the striking feature of this plan?
Uh, it has got 9 columns.
What is the striking feature?
What is the striking feature? I don't know, sir.
Look at it. Doesn't it? What makes it so appealing to you?
Too many.
What gives beauty to this drawing? Hmm? Can't you observe the similarity in the drawing? Can't you observe the symmetry in the drawing? Doesn't it look symmetric? Absolutely.
Yes, yes.
Okay, so symmetry is what is evident from this plan. Now, I will also draw one more plan. Assume that all the columns are of the same size. Okay, so here it is symmetry, here you have asymmetry. Okay, now let us consider this case, the elevation of both the buildings. So mass, let us take it as m. Here also elevation of the building. Let us say the mass is such that the mass is going to remain the same. Now, when earthquake is occurring, what is going to happen? When earthquake strikes on this building, what is going to happen? An earthquake load is going to get induced on the mass. Where will it get induced on the mass? It will get induced on the center of mass of the mass. So earthquake force is going to be induced on the center of mass of the mass. So center of mass, that is the point where the earthquake load is going to get induced. Is that idea clear? Clear or no? Clear or no? Center of mass is the point where the earthquake load is going to get induced, just like center of gravity, where the entire gravity force is going to be concentrated. The center of mass is the point where the earthquake load is going to get induced. Clear ആണല്ലോ? I hope it is clear to you. Now what is going to happen is uh, this will deform, right? Now under the action of the load, what will happen is the building is going to deform. So let us say this building deforms. So in this fashion, the building is going to deform. And when the building deform, what will be the tendency of the column? The tendency of the column will be to come back to its original position. How does it do that? It does that by developing elastic restoring force, because it is like a spring. So elastic restoring force will be developed. Let us say the restoring force developed in each column is Fr. Restoring force developed in each column is Fr. So basically, the force that is induced, how is it resisted? It is resisted by the elastic restoring force developing in each of the columns. Okay. So basically, now at the plan level, what you are having? At the center of mass, what you are having? You are having the earthquake force. And what is at the level of each of the column? You have Fr, you have Fr, you have Fr. So this is going to be there in all the column. Now if the arrangement is symmetric, if the arrangement of the mass is symmetric, then the center of mass is going to be at the center. If the arrangement of mass is symmetric, then center of mass is going to be at the center. If the arrangement of columns is also symmetric, where will the centroid of all these, where will be the resultant of all these forces acting? Anybody? If the, are you getting my question? Are you getting my question? ചോദ്യം മനസ്സിലായോ? Amin safe. Amin, can you understand? Are you understanding the question, Amin? Amin, are you alive?
സാർ അങ്ങനെ ഇല്ലാന്ന് തോന്നുന്നു.
Okay, okay. ഇതാരാ?
ഡിബില.
ഡിബിലി പറയൂ.
ക്വസ്റ്റ്യൻ കൂടി പറയാം.
ക്വസ്റ്റ്യൻ എന്താന്ന് വെച്ച് കഴിഞ്ഞാല് സെന്റർ ഓഫ് മാസിന്റെ സിഗ്നിഫിക്കൻസ് മനസ്സിലായോ? അതാണ് പോയിന്റ് വേർ ദി എർത്ത്ക്വേക്ക് ഫോഴ്സ് വിൽ ഗെറ്റ് ഇൻഡ്യൂസ്ഡ്. ഇനി സെന്റർ ഓഫ് മാസ് എവിടെയായിരിക്കും? ദാറ്റ് വിൽ ബി ദ, if it is a symmetric mass distribution, it will come at the center. Okay. ഇനി റീസ്റ്റോറിംഗ് ഫോഴ്സ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എവിടെയായിരിക്കും ഡെവലപ്പ് ചെയ്യുന്നത്? ഓരോ കോളത്തിലും റീസ്റ്റോറിംഗ് ഫോഴ്സ് ഡെവലപ്പ് ചെയ്യും. കോളം അറേഞ്ച് ചെയ്തേക്കുന്നത് സിമെട്രിക് ആയിട്ടാണെങ്കിൽ ഫോഴ്സുകളുടെ റിസൾട്ടന്റ് എവിടെയായിരിക്കും വരുന്നത്? സെൻട്രോയിഡിൽ തന്നെ ആയിരിക്കും വരുന്നത്. ഓക്കെ. റീസ്റ്റോറിംഗ് ഫോഴ്സുകളുടെ റിസൾട്ടന്റ് പാസ് ചെയ്യുന്ന പോയിന്റ് പറയുന്ന പേരാണ് സെന്റർ ഓഫ് റിജിഡിറ്റി. ഓക്കെ. റീസ്റ്റോറിംഗ് ഫോഴ്സുകളുടെ റിസൾട്ടന്റ് പാസ് ചെയ്യുന്ന പോയിന്റിന് പറയുന്ന പേരാണ് സെന്റർ ഓഫ് റിജിഡിറ്റി. Is that idea clear? So two points are there. One is center of mass, another one is center of rigidity. Center of mass means the point where the earthquake force will be induced. Center of rigidity means the point where the resultant of the restoring forces pass. Okay. If symmetric, എന്ത് symmetric ആ? Distribution of mass and distribution of stiffness. ഇത് രണ്ട് symmetric ആണെങ്കിൽ the center of mass and the center of rigidity both will be the same point. ഇത് രണ്ടും ഒരേ പോയിന്റ് ആയിരിക്കും. What will happen? They will cancel each other. Are you getting it? They will be more or less cancelling each other. At least they are collinear, they are in the same line. If so, Debil, can you say what will be happening in this case? Can you say what will be happening in this case? രണ്ടാമത്തെ കേസ്. ഈ കേസിൽ എന്തായിരിക്കും സംഭവിക്കുക?
രണ്ടും ഡിഫറെന്റ് പോയിന്റിലായിരിക്കും.
Exactly. The earthquake force will be here. Can you tell me where will the center of rigidity come? To the lower side or the upper side?
Lower side ആണോ?
Lower side, because we have more stiffness here. More columns means more stiffness.
Yes.
Okay. So center of rigidity will come here. These two are equal and opposite if we want to require equilibrium. Two equal and opposite forces separated by a distance, what will happen?
Exactly.
The bending is now going to twist. Okay.
Yes.
So what are the case where the building will twist? If there is an asymmetry in the mass or an asymmetry in the stiffness or both. If there is asymmetry in mass or asymmetry in stiffness or both. In both cases, what will happen is the building will twist. Okay. So this is the
Yes,
basic
sir.
idea of torsion. അപ്പോൾ ഇതാണ് സംഗതി. ഇനി നമുക്ക് പഠിക്കാനുള്ള ടോപ്പിക് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഇറഗുലാരിറ്റിയാ. Okay, I think this is too much. I am also feeling too much. I think we will stop. Okay.
Thank you, sir.
In the next class, we will be starting with irregularities. And irregularities is part of module 5. Module 5 is fully irregularities. Module 4 is over. Module 5 is irregularities, and we will be dealing with irregularities in module 5. We will finish module 5 tomorrow. And in the next class, we will deal with module 6. Okay. So this is it for today. Okay, I will be sending you one question which you can do and upload in the ET lab also. I will upload this lecture also. Okay. All the best.
Okay, sir.